Alright, here we want to look at sketching of isometric objects. Sketching of isometric objects when we are given the orthographic views of the object that we are to produce its isometric view free-handed. Let's look at the instructions so that we will know what we are to do and the views that we have here, what they are all about. The instruction says that the figure below or above shows a block in third angle projection. Make freehand isometric drawing of the block, making X the lowest point. Making X the lowest point. So here we have X, which is the lowest point that we are asked to focus on. And then, so looking at what we have here, we are told that the views are made in third angle projection. So what is third angle projection? I believe you have been taught orthographic projection. We have two types of orthographic projection. We have first angle projection and third angle projection. So what is the difference between the first angle projection and the third angle projection of orthographic projection? I'm going to show you here before we solve this problem. For the first angle projection, so here we have first angle. We have first angle. So we usually make use of 4 quadrants whenever we want to produce orthographic views of an object. So here is the first quadrant, here is the second quadrant, here is the third quadrant, and here is the fourth quadrant. Now, in the first angle projection, the front view of an object is placed in the second quadrant, and the plan or the top view is placed in the third quadrant, and the side elevation or the end elevation is placed in the first quadrant. So here we have the end view or the side view here. That is the first quadrant as first angle. Now, in the third angle projection, third angle projection of orthographic drawing, so we also have 3 quadrants. We have the first quadrant, we have the second quadrant, we have the third quadrant, and we have the fourth quadrant here. Now, in the third angle projection, here we have the top view here. Top view is put in the second quadrant, and the front view occupies the third quadrant, and the end view or side elevation occupies the fourth quadrant. So these are the differences, or this is the difference between the first angle projection and the third angle projection. So let's go to the question so that we can answer the question quickly. So this question that you see on the board is a simple question. I want to start with a simple question so that as time goes on and we are coming across complex questions, you will be able to do it yourself. Okay? Now, as we are told in the instruction that these views were produced in third angle projection. So it means that this is the top view and this is the front view. As you can see it here, top view, front view. So that's what we have here. Okay? Now, for you to produce this, and let's look at the features of the object that we are to produce. We have a square. This is a square, and we have another square inside it. So the outer square has a length of 40 millimeters, while the inner square has a length of 30 millimeters. And this is the front view. So the height here is 60 millimeters. And look at this very well. You will see that we have short dashes line here and we have short dashes line here. So what do they represent? They represent this inner square, that when we produce that isometric object, something will be hidden from us when we are looking at it from outside. So if you look at this, this is a square prism with a square hole inside it. So that's what we want to produce. And we want to do it free-handed. We want to sketch it free-handed. So let's look at how this can be done. So the first thing that we need to do is to draw the horizontal projection line free-handed. Then in the question, we are asked to make X the lowest point. So the lowest point. So you put a dot somewhere here, and you call it X. So this is where we are going to have the lowest point. So if you look at the top view also, we have the lowest point here too. We have X here. So, and if you look at it, what we are going to do is that we are going to have this at the bottom, and we are going to have the same thing at the top. So that's why this point X also, we also have it here. So the next thing that we are going to do, as we know that isometric objects are always inclined at angle 30 degrees, we have two receding lines. So the left receding lines and the right receding lines, they are inclined on axis, they are inclined at angle 30 degrees. So you take your protractor. So this is your protractor, take angle 30 degrees with your protractor. So you are not to draw it with a ruler, just take 30 degrees, place your protractor at this point, read angle 30 degrees and the degree to the left and also 30 degree to the right, and then use your hand like this. So to join the point together, supposing we have the point here, and also you also do the same thing on this side. So you have this. So now the next thing that we are going to do is that we draw a vertical line like this. So draw a vertical line. So after produce the vertical line, so we are told that from here to here is 40, from 1 to 2. I have numbered this 1, 2, 3, 4. So from 1 to 2 is 40 millimeters. 40 millimeters, and from 1 to 4 is 40 millimeters. So 1 to 2 now, from 1 to 2. So with your ruler, just take 40 millimeters from here to here. You can measure it. 40 millimeters from here to here. And then again, so this is point 1 now. Here we have point 1, which also happens to be the lowest point. Here we have point 2. So here we have 2 here. Then with your ruler again, take 40 millimeters. You are not to draw it with your ruler, but you can use your ruler to take the measurement. So here we have 40 millimeters. So this is point 4. So point 3 will be hidden from us. It will be hidden from us because this is an isometric object, so it is hidden from us. Then the height is 60 millimeters. So with your ruler, take a measurement of 60 millimeters. So let's say we have 60 millimeters here. Okay. Now, from this point, draw a vertical line. Draw a vertical line, free-handed. You are not to make use of your ruler, free-handed. You can only use the ruler to take the measurement. Okay. So draw a vertical line. Then come to this point also and draw a vertical line like this. Alright, so having drawn these vertical lines, so come here and take a measurement of 60 millimeters. So we have it here. And here also a measurement of 60 millimeters. So we have it what? We have it here with your ruler. But you are not drawing the lines with the ruler. So but you can use your ruler to take the measurement. So join this point together. Join this point together. So let's call this, we have this point 1 at the top. This is point 2 at the top. Then you draw this, join this together here. So this is point 4 at the top. Okay. Then the next thing is you produce a line in this direction, free-handed. Free-handed. Then take a measurement of 40 millimeters from here to here. 40 millimeters from here to here. Okay. Then you join this together. So join this together like this. Okay, so we are doing it free-handed. So this is point 3 at the top. We see it at the top. But at the bottom, we cannot see point 3. It is hidden from us. So I'm looking at this line that, so let it come a bit here. Okay, so we have it here. So the next thing is, we have to produce the inner square. We have produced the outer square. We need to produce the inner square. So with your ruler, so take a measurement of 5 millimeters. If you look at it, this, so from here to here is 30. So that means from here to here is 5, and from here to here is 5 millimeters. So take a measurement of 5 millimeters from here to here. So from here to here 5 millimeters. From here to here 5 millimeters. So with your ruler you can do that. Then from here to here 5 millimeters. From here to here 5 millimeters. Okay. Then so produce this line. So let this line. So you produce it free-handed. You can clean. So any line that you don't need, you can clean it. So produce this to the other side, and also produce this to the other side like this. Then this line, take it to this side. You can stop it here, and also take this one. So bring it here. So you can clean. Okay. So I have this now. So I can, this is not okay. Alright, so I can rub this off. I can rub this off, and I can rub this off. Then I can rub this off. So this can be rubbed off. So I can rub this off. So if you look at it, if it is not straight, so you can clean it and redraw it. So just take your time to do it. So you can clean this, so you can rub this off, and also remove this. Alright, so we have what? We have the top square or the inner square on the top part of the object. So now, so you can't leave this object like this. You can't leave it like this. It's not complete yet, because what we have here is a square hole. So this line that we have that's hidden, short dashed line that shows the hidden part of the object, when we are looking at it in this direction or in this direction, so we have to put them there. So the lines are not yet there, but we are only putting one there. So with what we have done here, we have not shown that we have a square hole inside this object. So what you need to do is to show that there is a square hole, or there is a hole inside this object. So you just come to this point here and draw a line down like this. So is the line straight? Let me clean it and redraw it like this. Okay, so I believe that this line is straight like this now. So I believe that it is straight. So having done this, we are done with the question. So with what we have done here, it shows that there is a square hole inside the object. So this is freehand sketching. We have answered this question. So the next one that I will be doing, so I will also take a simple one so that you can get it and you can be able to do it yourself. Thank you for listening, and God bless you.